Now that we have the basic idea of how forces relate to motion, it's worth taking a closer look at the force of friction. Friction is often stated as a force that opposes the motion of an object. When the object slides along a surface, we call this kinetic friction. The amount of friction depends on how firmly in contact the object is with the surface. For this reason, we say that friction is proportional to the normal force between the two. The coefficient of friction is a number which quantifies how easily the two surfaces tend to slide against one another. Typically, values are less than 1, with a value of 0 corresponding to a frictionless surface. This formula for kinetic friction applies whenever sliding occurs, regardless of the speed or acceleration. If, however, there is no motion, friction can still be present. In the stationary case, we call it static friction. Static friction doesn't have a regular formula simply because we need to obey Newton's first law. If there is no acceleration, then the net force must be 0. So if you apply 100 newtons of force to the cow, but it doesn't move, static friction must also be 100 newtons. If you then double your efforts and still the cow isn't moving, static friction must also have doubled. The best rule for calculating static friction is that it will be whatever it needs to be in order to make the net force 0. The one exception to this is when you have an object that is just on the verge of moving. There's an upper limit to the amount of static friction that's available. The maximum static friction is proportional to the normal force. However, the coefficient of static and kinetic friction are different. Take a look at the following question to see how they compare.